right, this is section 7.4, adding and subtracting rational expressions. In the last section, we talked about how we found a least common denominator, and we talked about rewriting them a little bit. Our addition and subtraction rules with irrational expressions, they are exactly the same as they are with regular numbers. You have to have a common denominator, and then once you have the denominator the same, you add or you subtract across the top, and the denominator does not change. Okay? Then we have to make sure our answer is in lowest terms. Unfortunately, there's no way to reduce before we add or subtract, so cross cancellation does not work. Multiplication is the only operation that allows that. So we have another time where we have multiplication rules and division rules on one side and completely different addition and subtraction rules on the other. So let's just get a quick couple of problems worked. We want to add 4 over m plus 7 over m. Now, they already have a common denominator of m. We don't know what m is. It doesn't matter what m is. It's the same. So we add across the top, and I'll write out this step for right now. And then do the arithmetic. 11 over m should be our answer. Let's look at this one. This one's a little bit trickier because we have a minus sign and we have a complicated numerator. So go ahead and put these in parentheses. It matters less when it's addition. Subtraction, it really matters. I do have a common denominator here. So I'm allowed to subtract across the top and then keep that denominator the same. Now, why are the parentheses so important? Because that's a -1 that needs to be distributed. Technically, that's a 1 there. You can think of it as distributing a 1, but of course that doesn't change anything. So I can drop these parentheses. I have x minus y minus x minus y. Now, if I go to combine like terms, this is all over 2. If I go to combine like terms, I have x minus x. That goes away. Negative y minus y is negative 2y over 2. Now we have added, subtracted, that's what I meant, and now we need to reduce. I have negative 2 over 2. I can divide that to get a -1, and that's now a 1. So your answer, you could either write -1y, but better would be -y. Okay, one more, where we have the same denominator. Y plus 3 is my denominator in both of them. So my denominator is going to stay that. Now I have an addition, so I'm going to add across the top, y squared minus 3y plus a -18 over y plus 3. And this, of course, is y squared minus 3y minus 18 over y plus 3. So we've done the addition. That part's done. Now we need to see if we're in lowest terms. And to find out if we're in lowest terms, we need to factor everything. This doesn't factor, that's why I kept it in parentheses. But here, I need to see if it does. It might not, but we have to check. So if I look at this, I do not have a GCF. 18 is not a perfect square. So I need to be looking for two numbers that multiply to a -18, that add to a -3. Things that multiply to 18 would be 1 and 18, 2 and 9, 3 and 6, and that would be it. Multiply to a -18, so one of these needs to be negative. If I make it a -6 and a +3, that should work. So the top factors as y plus 3 times y minus 6, and this is over y plus 3. And now ask yourself if you have anything that cancels out, and I have a y plus 3 in both of these. So since I have nothing left in the denominator, my answer is y minus 6. You can keep that in parentheses if you want to. It's still correct if you do, but you don't need them anymore. That should be your answer.